the I2C driver for Mega 644P. Here is the device at Mega 644P. Okay, is ready and it's working. You can see that I have find out the device connected. Right now the slave which I have connected uses the ARM board, ARM STM32F0. So here it is. So you can see the LED blinking. I have programmed as soon as it receives a character A from the masters. In this case master is at Mega 644P this board, and the slave is ARM STM32F0 Cortex ARM M0 board, discovery board. The board is STM32F030. You can have a close look over here for the discovery board. Here I have used the connection like this. The slave is taking the 5 volt supply from the master itself. This yellow line is the 5 volt supply, the green line is a ground, and here I have made the connection as per the I2C specs or two-wire interface specs. That means both SCL and SDL lines has to be connected to 5 volt supply with the help of 10K. I have used a 10K resistor over here, and you can most of the time 10K resistor will work, but when it comes to devices it is safe to calculate the resistance that we have to connect between SDA and SCL line, and the SDA SCL lines of ARM is connected to one place, and the same is being connected to VCC, and the same SCL of the master, that is in this case at Mega 644P, is connected to the same node, that 5 volt node. Okay, this is a device which is used to communicate to PuTTY or with the help of UR driver. This Atmega 644P is also having a UR driver. A custom printf scanner is also programmed for this board. You can see that right now the device is printed some values. In the sense, if you can get closer, I'm not sure why it is not zoom, why the image is blur. Okay, you can see that, yeah, you can see that the values. Okay, this shows the possible addresses, that is 16, and this shows the 7 possible way address. So the slave address, that is 39, which has to be left shifted while transmitting a slave address. This slave address of ARM I2C has given an address of 72, which can be seen over here. This is ARM code in which it is configured with the address of 72. 72, when it is right shifted, it will become 39. So that 39 is used as a slave address over here. You can see that this is a slave address. Okay, and as soon as ARM slave has been configured as a slave receiver, that is ARM is configured for slave receiver. In this sense, as soon as it will get the interrupt, it will check for the character, and in the character, if the received character is 41, that is ASCII value of A, character A, then I'm just toggling the LEDs. So in this case, you can see that it is configured. Character A has been uh, uh, put it into transmit buffer, and once the target communication is done, it will start blinking the LEDs. Okay, maybe I'll reset the board. Now you can check the board. I'll reset the ARM board, that is slave. Okay, the LED stopped glowing, and then I will also reset the master, that is in this case ATmega 644p. Okay, you can see that it got reset, and soon the LED started blinking. As soon as it started communicating, LED started blinking. So in my code, uh, I also have uh, the device discovery part. I can show you the code for that. Um, so this is the part where it will discover the connected devices to this master, that is ATmega 644p, and it will print all the devices which are connected. So right now, and after that I've configured this as a master again, and I'm transmitting the character A to the slave, that is ARM board, in this case STM32F0 board. So you can see that I'll reset once again, and then you can check the values. Okay, so I'll reset the slave, I will reset the LED stopped glowing, I'll reset the master. Okay, the lights have started blinking, and meanwhile here it will discover first and then start transmitting. Once it is discovered, you can see that the device slave address, which is right shifted by 1, has been printed over here. So while passing this value, you have to make sure that you have left shifted this value, whatever 39, by 1. Okay, so because LSB bit will be the read or write bit, in my case the value 39, address 39 has been given, and in the interrupt part of the code, the value has been left shifted by, address has been left shifted by 1. This is the address where it will get connected, and it is left shifted by, and based on the mode it will be either transmit or receive. So this code will be shared anyway, you can enjoy. The setup.